Hello everyone, I am Arindam Chakraborty, Assistant Professor of S.V.I.S.T, Kolkata. In today's class, we'll learn about friction. So, in today, we'll discuss about what is friction, what are the applications of frictions, types of frictions, limiting frictions, and laws of friction. Now, what is friction? As per the definitions in books as well as per the research, it is termed as the resistive force when you apply a force or a motion. So, for this is one thing. Second thing is where it will happen. It will happen when two surfaces comes in contact to each other. So, let me make it more easy for you people. Let us consider an object 1 and another object 2, which both of the objects came in contact to each other in this surface. Now what I did is I applied a force on object 1. So what will do? As per the theory says, there will be an anti-force or friction which will be acted from object 2. Okay. Now, is this a theory or it's a practical phenomenon? It's a daily life. Everywhere you can find friction. Friction, to understand it in easiest way or in a deeper meaning, we have to understand one thing. Let me show you one thing. This is an object 1. Here you can find that is there is a red colors cones. These cones depicts the surface of the object 1, which came in contact with object 2. Therefore, even object 2 has this type of cones. Thus, what did I mean to say? What I mean to say is, it is impossible to get a complete plane surface. You will find the irregularities in the surface. So that's why we don't say smoothness of a surface. When you will study in higher studies, higher semesters, you will find there is no word called smoothness rate. You can find roughness rate. Okay. So for that we use one machine named telesurf. That's a other thing. But as if for now, try to understand. That means we getting a complete smooth thing is impossible. It's an ideal case. So since it's an ideal case, we have to understand what what we get in every surface. For every surface, if we take it to a microscope and we zoom it and we magnify it a larger time, we'll find that the surfaces are not actually smooth. What you will get? You will get irregularities like hills or hill range or something like valley. You can find like this. Fine. So what happens over here? The simple thing is that this red cone get attached to the yellow cones. So what happens? Since they get connected to each other and they get interlocked. For what happens after interlocking? When you apply a force, then this yellow irregular particles part of object 2 resist that force, which creates friction. Okay, so let me make it more easy. So for understanding it, let us consider one of object 1, one cone of object 1, or one mountain peak of object 1. Okay, another cone of object 2. Okay, it's 1 and 2. What happens? You are applying a force in this manner. Fine. So what it will do? It comes in contact to each other. Fine. So what will it do? It will resist it. So how it will resist? It will apply an anti-force. Okay, this is what friction is. Am I clear? Okay, let's go. Okay, so it is clear that object, when force is applied, there will be an anti-force. Fine. Why? Because the intermolecular locking. Okay. So, or you can say interlocking of the surfaces, not molecular. That will be a more, that is due to interlocking of surfaces due to crest and mountains. Fine. Why do we apply friction? We apply friction everywhere else, like gripping a pan or walking, even while we are swimming. Even you may be aware of aircrafts, even they experience a friction. That's why the coating of aircraft, that is the paint done on the aircraft, you have to be selected in such a manner that the minimum amount of friction can experience, an aircraft can experience. But there is an air resistance also. So everywhere you can find it. You can't deny it. Correct? Now, let us understand it in a easiest way. When we make one of our foot forward, applying a force forward, so we will be applying another force on the backward. So what happens is, for the friction of the the backward leg, we are moving towards the forward leg. Now, why? There's one question. Why I am telling the backward leg? Because if there is no friction, this leg should have slipped. Okay, this is getting interlocked due to only friction, which is helping us to move our body just towards forward. Now, same like this happens for a swimmer. What happens? He gives a stroke over with this hand, and what it happens? He pushes himself towards the forward direction. So what happens? He gets a drag force. This is nothing but, that means he goes against the water. So this makes a resistance. That is called fluid resistance, where you can see over here. Okay. Same goes with the wheel or a cylinder which is rolling. What happens? When you push this wheel will roll. And what will happen? This will roll towards forward direction, but the friction force will always work at the backward direction. Fine. So you can find friction anywhere, like opening a cap of a bottle. Okay, like holding a mouse. If it was a frictionless, it would have slipped from your hand. So you can find friction everywhere in your surroundings. Now, what are the types of friction? For understanding the types of friction, you have to understand what happens. First type is static, second is sliding, third is rolling. What is static friction? When there is no movement and the objects are in rest. This is called static friction. Now, then my question comes. So if there was no friction over here, what would happen? One would have slipped over another. That means they would have slided. Fine, they would have slided. That is what happening. That's why static friction is acting in every point where an object is being placed. Now, what is sliding friction? When we rub hand, what we do? One hand goes forward, one hand goes backward. That creates a friction named sliding friction. Rolling, as I have told you, the rotation of wheel on its surface. What happens when you apply a force on the wheel? It rolls and it moves forward. But if there was no friction, it would have slipped on the way. So there would be an accident in everywhere, every road. So for resisting that one, we have friction who governs over it and makes the road safer. Now, what is limited friction? Make it very easy. It's the same as friction law. What is friction law? It's a mathematical explanation of friction. Very precise. To be very precise and very easy is that it gives a mathematical explanation how friction works. So that will make you very easy to understand. Now let me consider object 2 to be in rest. Similarly, object 1 in motion. What will happen? Object 1 is moving with a force F, which happens to get a friction force FF. But there is a catch. The catch is, since this object 1 will have some mass, that means mass means there will be a weight. The weight will be applied on object 2. So what will happen? I'll get a normal force acting upwards from the surface, but the normal will be 90 degree. What do I mean? There is a 90 degree force acting from the surface where it came in contact. Now, why it came? Why the normal came? The reason behind of this is Newton's third law of motion. Newton's third law of motion states every action has equal and opposite reaction. Now try to understand. This is a weight, that is a force. So this will get an anti-force, or this will get not anti-force, this will get an opposite, in other words, opposite and reaction force. This will be get a reaction, that is a normal. So mathematically we can say that this friction force FF is directly proportional to the normal. Fine. So what we can do, I'll show you about this one. This is according to the first law of friction. I'll come with the laws in the second, in a few minutes. What happens? I get a mathematical explanation. What is the mathematical explanation? Friction force is the product of mu into n. Now try to understand. What is mu? Mu is the friction coefficient or friction ratio between object 1 and 2. Fine. And n is the normal due to the object 1. That's make the sense. That is, friction force, amount of magnitude of the friction force is mu into n. Now let us understand with the help of laws of friction. What is the law? First law of friction. First law of friction states that friction force is directly proportional to the normal. As I have seen that friction force is equal to mu into n. From the concept came from here itself. That is first law of friction. That is, friction force is directly proportional to normal. So to simplify it, what we apply? We apply mu. Mu is a coefficient of friction. Second law states that the friction is independent on the area of contact. What does that mean? That means the area is independent. Now, that means be a point. That means a point which may be connected to the surface, or that may be a whole bunch of the body connected surface connected to another surface. So it is independent of the area which is being contact. Now the point is, that means there should be a contact. The thing is that there should be a contact, physical contact. This is what it means, friction. As you can see over here, what is this? A circular, a sphere or a circle could have a friction. A cylinder could have a friction. A small pointed like this triangle could have a friction. So friction, you can't get aware of friction. You have a friction, where is a contact. Now, number 3. Number 3 states that coefficient of static friction is greater than kinetic friction. Why? In kinetic friction you have a motion, but the motion is restricted by, as I have showed you in the while rolling of a cylinder. So that means that static friction is coefficient of static friction, that or the friction ratio will be maximum compared to kinetic as well as compared to dynamic, kinetic or dynamic friction. Now, this is same goes for the static means the rest. That's why I have made these 3 points so that you could understand that this three things are the same way only. Static means rest, kinetic means dynamic, and dynamic means also motion. So these 3 means the same. If you get anything that written that mu static is greater than mu motion, this what the thing which means is the same as mu static is greater than mu dynamic. This 3 is written to make you understand in certain books or certain certain areas you can find that it is written that mu static is greater than mu kinetic. This is same thing which it means. This means this is same as mu static, mu dynamic, mu rest, mu motion. The same thing. The main thing is that main catch is that static coefficient of static motion friction is greater than coefficient of kinetic friction. Fine. The main goal is this. That now you could change the word. You may not use the static. You may use rest. You may change the word kinetic to dynamic or motion. So that's what I mean to say. You change the word, but the phenomenon will remain same. That means mu static is greater than mu kinetic, mu static is greater than mu dynamic, mu static is greater than mu motion. That all the 3 things are same. Like mu rest is greater than mu kinetic, mu rest is greater than mu dynamic, mu rest is greater than mu motion. The same thing. The thing is we are changing the names. Okay. Now, the thing is that number 4, friction depends upon the nature of surface in contact. This is one of the most important things you need to understand. The thing is that is it a solid contact or solid liquid contact, or it's a solid gas contact. So everything will have a friction. The amount of friction depends on what type of contact it is having. Fine. What type of surface is there, what type of contacts are it having. Now, as I have told you that the friction coefficient of friction is slightly greater than the kinetic friction, as I have told you. So you have to, as I have stated above. Now, one more thing I have to tell you, that one more law, that is about the velocity relation with the friction. Velocity is independent of kinetic friction, whatever the velocity may be, but it would be in a larger limit. When you are talking about a larger limit, or you are talking about a big picture, at that time velocity is independent. That means velocity doesn't make any sense for kinetic friction. This is what I want to say. So let me summarize. First, friction force is a product, is directly proportional to the normal force, or mathematically we can write friction force is equals to product of mu, that is a coefficient of friction, and normal from the surface of contact. Second, it doesn't depend what type of contacts are there. It may be a point contact, it may be a line contact, or it may be a surface, a complete area contact. So it is where is a contact, there will be a friction. Third is the most important, that for larger picture, that means when you are talking about a large limit of forces, large limit of velocity, so if there is a kinetic friction, the velocity doesn't make any sense. But when you are talking about the smaller things, or some you are talking about small pictures, then small perceptions, then where the velocity comes in action. Fourth is it depends on the nature of contact. Like aircraft which is flying, it shouldn't have, as per our normal conception, like as daily basis everyone have, that would I think we think that aircraft doesn't goes for a friction. Yes, even aircraft has a friction, like solid with gas friction, with gas, that is the air is a gaseous medium, but solid with liquid friction, liquid solid to solid friction. So everything, as well as liquid frictions, like what we see in fluid viscosity, so everywhere you can find. Number 5 is it states that coefficient of static friction, that is mu, is greater than the coefficient of kinetic friction. That is all I have to say for today. If you have any queries, anything you need to understand, just contact me. Feel free to contact me. Thank you and have a nice day.